All right, this video we're going to finish out question 2. It's parts D and E. And let me first, there we go, do that. Perfect. All right, so I have had a good deal of questions on questions like D and a little bit on E. So looking at D, remember the first step in solving these types of problems is getting the sine or the trig function by itself. So right now we have the sine of some stuff inside times 6. And so we want to divide by 6 on both sides. And this is where I get questions. I have students asking me, well, what do you reduce on the left side? Like, do we have to leave that -3 times square root of 2 over 6? And my point that I make is that the -3 on top and the 6 on bottom can reduce. So -3/6 is just -1/2. And we still have the square root of 2. It looks like a cursive Z is what that is. Square root of 2 up top. So the 3/6 becomes 1/2, and we haven't done anything with the square root of 2, so that just comes to negative square root of 2 over 2. And that is equal to the sine x plus 5 pi over 6. All right, now next thing we're looking to do is take that sine, arc sine is -1, of negative root 2 over 2. And that is going to, by taking arc sine of both sides like that, that's our left side. Our right side just reduces to just x plus 5 pi over 6. Continuing on to this next page down below. So what we're looking for is, and I'm going to flip-flop so that the x plus 5 pi over 6 is on the left side of the equation. So the arc sine of negative square root 2 over 2, well, root 2 over 2 is a 45-degree angle reference, and sine is negative in the third and fourth quadrant. So let's see, 45 degrees in that quadrant, 5 pi over 4. And all of these, if you look back at the instructions above, solve for all values. So in doing so, that's taking our answer plus 2 pi n. And the other answer for arc sine of negative root 2 over 2 is in the fourth quadrant, so 7 pi over 4 plus 2 pi n. Now we take our last step, and that is to get x by itself. So we subtract 5 pi over 6 from both sides. And our final answer, x equals 5 pi over 4 plus 2 pi n. Subtracting 5 pi over 6, we need to reduce that. I cannot leave that. I need to combine the 5 pi over 4 and the minus 5 pi over 6. And what that looks like is getting a common denominator. So 12 is our least common denominator. And to get that reduces to 15 pi over 12, right? Because we took the bottom times 3, we take the top times 3, minus, no, 6 to get to 12, we doubled, so that's 10 pi over 12. plus 2 pi n. So 15/12 minus 10/12. Your final answer, 5 pi over 12 plus 2 pi n. That is one answer. Now, the same thing is happening over here with x plus 5 pi over 6 when it's 7 pi over 4 plus 2 pi n. That one, I'll carry this down to here just because we need the room. So this looks like x equals 7 pi over 4 plus 2 pi n minus 5 pi over 6, which equals, in terms of twelfths, that's 21 pi over 12 minus, again, 10 pi over 12 plus 2 pi n. So x equals, let's see, 21 minus 10, that's 11 pi over 12 plus 2 pi n. So there you go. Two answers, 5 pi over 12 plus 2 pi n, or 11 pi over 12 plus 2 pi n. I am going to pause this just so that I can simply erase a bunch of this work here temporarily so that I can do letter E. So give me a second. Bam, just like that. We've got it cleared off. So we are on to letter E. We're trying to, again, first get cosine by itself. So in doing that, when you have an addition or subtraction, when you have addition, subtraction, and a multiplication, we have -3 and then we have 2 times cosine. You need to do the adding, subtracting first. Get rid of adding, subtracting on that side first. So in this case, the first must do is to add 3 to both sides. Do not try and divide by 2 first, and you'll see why in a second. Well, I'll just tell you, if you were to divide by 2 first, you'd have to divide the -2. Sure, that divides by 2 nicely. But over on this side, you have 2 more terms, and you would have to take -3/2, and then the 2 would reduce out. So you've added a fraction in that's not necessary. If I add 3 to both sides right away, I get 1 is equal to 2 times cosine of x over 2. And now, see, now to get cosine by itself, now we divide by 2. And that is a much easier process. So now 1/2 is equal to cosine of x over 2. Now this is actually a really simple process to do that, right? So we take, I'll start down here, over here, and I'll say arc cosine. So arc cosine of 1/2 equals x over 2, because we took arc cosine to the right side, we got rid of the cosine, and we took arc cosine of 1/2. So again, in the spirit of keeping our variable on the left side, all I'm going to do is flip-flop. So x over 2 equals, and then that's going to be whatever the arc cosine is. So where is cosine's ratio 1/2? And cosine is positive in the first and fourth quadrant. It's relating to our x terms. So that would be at pi over 3 plus 2 pi n, or x over 2 is equal to the fourth quadrant, reference angle 60 degrees, or pi over 3, and that would be 5 pi over 3, kind of hard to see, sorry, plus 2 pi n. So the two answers we have, pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n, need to be multiplied by 2. And so I say, 2 times that, and this whole thing times 2, this whole thing times 2. So what we have is x equals, sorry, didn't mean to do that. So that should be 3, there we go. And x equals 5 pi. So those are our two answers, and if we keep going to the right for each of those, we have to distribute that 2 to the pi over 3, so we get 2 pi over 3. But we also have to multiply the 2 to the 2 pi n. So 2 times the pi over 3, 2 times the 2 pi over n. So that's plus 4 pi n. Down here in the lower one, 5 pi over 3 times 2 is 10 pi over 3. Also plus 4 pi n. So box in answer 1 and box in answer 2. So again, I would say question 2, letter E, is only the hardest problem from the sense that you have cosine being multiplied by 2 and 3 is subtracted from it. And again, please make sure, do the adding and subtracting first to get rid of it on that side that you have your trig function. Then after you've done your adding or subtracting, then you can do your dividing or multiplying. Eventually getting cosine by itself. Then take arc sine or cosine, arc trig function to undo the trig. And then once you've done that, the last step is to get x by itself. So there you go. That is question 2. We're moving on to 3 in the next video.